We often hear critics of evolution saying things like, a dog could never have evolved from a cat, or if humans evolved from monkeys, why are there still monkeys around? These kinds of statements reveal a misunderstanding of what scientists mean by evolution. Think of it like this: if you go to a family reunion, the people of the same generation are not descended from each other. They are related because if you go back far enough in the family tree, you'll find an ancestor they all descend from. Species we see today are like distant cousins on the family tree, but you have to go back many more generations to find their common ancestors. Even still, these cousins appear to be too diverse to share a family tree, but such change can happen because of variation and selection over lots of time. Since offspring differ slightly from their parents, some differences provide a reproductive advantage, and so these traits can work their way through successive generations, like some gazelles that are faster than their kin and can therefore more easily escape cheetahs and reproduce. This leads to more gazelles in subsequent generations that are faster. Some people call this microevolution. Positive variations are more often passed on and can cause the characteristics of populations to change over time, but this doesn't yet account for the different species we see today. Sometimes one part of a population becomes isolated. For example, through a rare event, a population of birds could colonize a remote island. New variations that occur in this island population will not be passed along to the group on the mainland. Over long stretches of time, variations in offspring and different ecological factors could even cause enough changes so that the island birds can no longer mate with the mainland birds. These kinds of changes take thousands of years. We see many of them in the Hawaiian Islands, the world's most isolated island chain. Not surprisingly, there are many exotic species of birds, insects, and plants that are not found anywhere else on Earth, but whose genetic heritage we can trace to continental species. This kind of evolution does result in distinct species, but these are still relatively close cousins on the family tree. To see the common ancestry of more distantly related species, we need to understand the ongoing variation over millions of years that can result in significant structural changes. Some people call this macroevolution. We'll look at this in our next video.